Okay, class, so today we are going to talk about, just in general, solving quadratics and deciding what way we want to solve them with. So we looked at this a little bit last Friday of sort of deciding what way we want to use. Okay, but today we now have quadratic formula included. And so really just sort of making that decision of what way are you going to use to solve a quadratic given a specific situation. So we have a couple options. Option number one is that you're like, I am just going to try and always stick with the quadratic formula. It does work all the time. My biggest concern with this is a time factor, okay, of you running out of time and not being able to complete in the time that you're allowed. On top of that, some of the skills that we know with factoring and completing the square are going to come up in future courses. Option two is that you just look at a problem and you sort of go, oh, it's set equal to 0, that's the factoring route, or that's the quadratic formula route, and you just sort of know. Option three is that I have a table, sort of a thinking map put together. It's linked on Canvas. You can print it or you can just have it available for you to use. That sort of walks through some things you might want to ask yourself as you look at a problem. The more you sort of use this, the less you'll rely on it. Okay, but up here in the top left, this bold box is sort of our starting point. And it sort of asks us some questions that we want to think about that will help lead us to the best way to solve. So, for example, let's say we are given a quadratic that says 2x squared plus 1 equals 39. Okay, so we're going to start up here in this top left-hand corner, and the first question says, is there an x to the first power? Is there an x to the first in the equation? So we're going to look at this equation. Okay, there is no x to the first power. So we can solve this by taking a square root. Okay, remember, solving by taking a square root is where we just start moving everything away and then using the inverse operation of an exponent of 2. So I can undo adding 1 by subtracting 1. So 2x squared equals 38. X squared equals 19. And then we will undo our exponent of 2 by square rooting. I can't, right, I would try and normally prime factor and simplify, but 19 is already prime. So we'll just get x equals plus or minus the square root of 19, right? That's two answers, positive square root 19 and negative square root 19. Okay, so let's look at another one. Again, I just want you to sort of get used to how you would use this list. So let's say we had x squared plus 6x equals 0. So again, if we look here, is there an x to the first power in the equation, right? Yes, right here there is. So we're going to follow now the yes line. Is it a binomial or a trinomial? Now, we can only decide if it's a binomial or a trinomial when it's equal to 0, right? We need all those sort of terms. Now, you could say, if it says x squared plus 6x equals 7, you could go, oh yeah, I know I need to count that 7. That counts as a term. So keep that in mind when you're considering, otherwise set it equal to 0, so you make sure you're counting them all. This is two terms. So this is a binomial, so I could follow that binomial line. It says factor out a GCF and set each factor equal to 0. So here's one where I could factor out a GCF. Okay, it's already set equal to 0, so I can factor out a GCF. It has a GCF of x. Okay, which means I can say x equals 0 and x plus 6 equals 0. And I can solve over here. This one's already solved. And so we'll have x equals 0 and x equals negative 6. Now again, the purpose here isn't to review all the ways of solving. You might need to go back and watch the other videos if I didn't give enough detail there. Okay, so let's look at another one, a third one here. Let's say we have x squared minus 10x equals 8. Okay, so is there an x to the first power in the equation? Yes, there's one right here, so we're going to follow the yes line. Is it a binomial or a trinomial? Well, we have 1, 2, right? This counts as a term because it's not 0. So we have 1, 2, 3 terms, so it's a trinomial. Does A equal 1? A does equal 1. So then it says, can you factor it as a trinomial? Well, that might require you to do some work. So we can check and see, right? To factor it as a trinomial, I would need it to be set equal to 0. So multiples of -8 that are going to add up to 10. Nope, I can't do this as a trinomial. So this would be a no. Now, if it was a yes, I could continue factoring, but it's a no. Is B even? Yes, B is even, so we're going to solve by completing the square. Okay, so completing the square says I'm going to find B, take half of it, square it, right? Then I'm adding that to each side. Okay, so over here I'm going to get 33. I'm going to factor my trinomial, which always goes into the middle piece. Then we're going to square root each side. 33 just goes into 3 and 11, so no pairs. So this is just plus or minus the square root of 33. We'll undo subtracting 5 by adding 5. And we'll get x equals plus or minus the square root of 33 plus 5, right? This is two answers. Positive square root 33 plus 5 and negative square root 33 plus 5. Okay, last one that we're going to look at, and again, I think at this point you should be going, okay, this list makes sense. So let's say we have 6x squared plus 8x minus 10 equals 0. Okay, so is there an x to the first? Yes. Binomial, trinomial to trinomial. Does A equal 1? No. Quadratic formula. Now, that doesn't mean that we couldn't solve it by factoring. Solving by factoring could be a possibility. I'm just saying I don't know if it's the best possibility given what we have. So this isn't like set in stone you have to follow. It's just a suggestion of some thoughts you might want to consider. So if we do the quadratic formula, it has to be set equal to 0, which this is. So A equals 6, B equals 8, C equals negative 10. So our quadratic formula says negative B plus or minus B squared minus 4 times A times C all over 2A. Right now, calculator, you can't, you can do it by hand, but why make your life more difficult if you need to, right? So we're doing 8 squared. Technically, right, we need parentheses, but when it's positive, it doesn't affect it. Minus 4 times 6 times negative 10. So we'll get 304. So negative 8 plus or minus the square root of 304 all over 12. Now we need to check this 304 and see if we can simplify it. So let's see. 2 and 152. 2 and 76. 2 and 38. 2 and 19. So 2, 2, 2, 2, 19. So 2 pairs. So let's see. So we'll have negative 8 plus or minus 4 square root 19 all over 12. And then for that last step, right, we're seeing what we can simplify here. And those are all divisible by 4 on this one. So negative 2 plus or minus, we could write the 1 there. 12 divided by 4 is 3, all over 3.